Right, if you read section 9.5 last time, you may have noticed that they defined a power series a little bit differently than I did. So I said that a power series looked like some constant, some coefficient times x to the n, where n ranges from typically 1 to infinity. So this is the one that I did. The book phrases this a little bit differently. This says we go from n equals 1 to infinity of, again, so some number that goes there, but rather than just x, it's x minus some other number. So this a is different than that a. But basically, there's going to be some shifts to which x value we're talking about. So an example of something of this format would be the series, let's say, so I usually use 1 plus x squared. This would be something like x minus, or let's say 3 plus 3 x minus 2 plus 3 x minus 2 squared plus 3 x minus 2 to the fourth, etc. So this is the series corresponding to the sequence an always equals 3. All right, so the interesting part here, or the difference, is this fact that we've got this x minus 2 rather than just an x. Oh, that was supposed to be a cubed down here, not a fourth. Cool. So the question is, all right, rather than, so it's an x over here and it's an x minus 2 over here. And the question is sort of what does this change? Well, I want to take a look at the GeoGebra model we've been talking about. So here we have the sequence that is centered at 0 that's approximating this cosine of x function. And the point is that this is going to be really close. This is going to be a really good approximation for what's happening right at 0. So we're going to say that this whole thing is, in this case, centered at 0. And we can see that, all right, as we increase the degree of the polynomial, we're getting a closer and closer, better and better approximation of this function, but it still is centered around 0. So we could do this exact same thing, but instead of centered at 0, it could be centered at some other number. That's where the a comes in. All right. So when we have something like this is going to be some sequence, or some series, but we're going to be centered at x equals 2, because it's x equals 2 that makes the this inside part drop out. So this is going to be some sequence, just like before, that is centered at x equals 2.